What if I told you humanity is trying to build something so tall that physics itself might say no? In the deserts of Saudi Arabia, engineers began constructing a tower that aims to reach over 2 kilometers into the sky, more than twice the height of any building ever made. This isn't just architecture. It's a battle against gravity, wind, heat, and the limits of materials themselves. And here's the twist. We don't actually know if it can be done, because at this scale, buildings stop behaving like buildings and start behaving like experiments in physics. Humans have always built upward. From ancient pyramids to modern skyscrapers, height has always symbolized power. The current tallest building, the Burj Khalifa, stands at 828 meters, but the proposed tower in Jeddah aims to go far beyond that. Not 1 kilometer, but potentially 2 kilometers tall. That's taller than 2 Burj Khalifas stacked on top of each other, most mountains you see from cities, even higher than some clouds. But here's the problem. As buildings grow taller, they don't just scale up, they change behavior completely. At small scales, buildings are simple. At large scales, they become unstable systems. Let's break this down. 1. Gravity. Every extra meter adds weight. But here's the catch. Weight increases faster than strength, so at extreme heights, the bottom of the building is being crushed by everything above it. 2. Wind. Wind isn't just air. At 2 kilometers high, wind becomes a force of destruction. It doesn't push steadily, it oscillates. That means the tower could start to sway like a giant pendulum. And if the frequency matches the building's natural frequency, you get resonance, which can tear structures apart. 3. Earth itself. At this height, something strange happens. The top of the tower is slightly farther from Earth's center than the base. That means gravity is slightly weaker at the top. The Earth's curvature becomes noticeable. The building is no longer just vertical. It exists across a curved gravitational field. Now imagine this tower in the Saudi desert. Temperatures can swing from cool nights to extreme daytime heat. That causes something called thermal expansion. When materials heat up, they expand, but not evenly. One side of the tower might be in sunlight, the other in shade. This creates uneven expansion, and over 2 kilometers, even a tiny expansion becomes meters of distortion. That can bend the structure, create stress fractures, and eventually, failure. Engineers discovered something fascinating. Tall buildings don't just resist wind, they must confuse it. When wind flows past a structure, it creates vortices, spinning air currents. These vortices can synchronize and create powerful oscillations. To solve this, modern skyscrapers are designed with twisting shapes, tapered profiles, uneven surfaces, all to break up airflow. The Burj Khalifa does this brilliantly. But at 2 kilometers, even these tricks might not be enough, because wind speeds increase with altitude. At the top, winds can be violent and unpredictable. Everything depends on materials: concrete, steel, composites. They all have limits. The problem: to support a 2-kilometer tower, the base must be incredibly strong, but also not too heavy and resistant to heat and stress. This creates a paradox. Stronger materials are often heavier, lighter materials are often weaker, so engineers are forced into a delicate balance. Some propose carbon fiber structures, advanced composites, even future materials we haven't fully developed yet, because traditional materials might simply not be enough. Now, imagine living at the top. How do you get there? Elevators today already struggle at extreme heights. Problems include cable weight, travel time, energy consumption. At 2 kilometers, a traditional elevator cable would be too heavy to support itself. So engineers are exploring magnetic elevators, multi-stage elevator systems, horizontal-vertical transport hybrids. Because otherwise, Getting to the top might take longer than a flight between cities. At this scale, we're no longer building structures. We're testing the limits of physics. A 2-kilometer tower sits at the edge of structural engineering, atmospheric science, material science, even planetary physics. Some scientists compare it to early attempts at flight. Risky, uncertain, but transformative. So here's the real question. Can we actually build it, or are we approaching a hard limit? Not a financial limit, not a technological limit, but a physical limit. A point where gravity wins, wind dominates, materials fail, and no amount of engineering can fully overcome it. We don't know yet. And that's what makes this project so fascinating. The 2-kilometer tower isn't just a building. It's a question, a challenge to physics itself. And whether it succeeds or fails, it will teach us something profound: how far humanity can go before nature pushes back. If you enjoyed this deep dive into extreme engineering, subscribe for more stories where science meets ambition, because the future is being built higher than ever before.